Hello everyone, I am Dr. P. Ramesh Babu, working as Assistant Professor in Computer Science and Engineering at Marri Laxman Reddy Institute of Technology and Management. In this session, I am going to be explain about the structure of the compiler. Before discussing about the structure of the compiler, we know about the translator. What is a translator? A translator is a program that takes as a input to a program written in a one language and produced as a output program in another language. Important role of the translators are translating high-level programming input into the equivalent machine language program. High-level language program is nothing but the human-readable language, and machine language is nothing but computer-readable language. Providing the diagnostic messages wherever the programmer violates specific of the high-level language. So there are three types of the language translators is there: compiler, interpreter, and the preprocessor. So compiler is a translator that translates a program written into high-level language, the source program, and translate into equivalent program, machine level language. It is nothing but the target program. So high-level language program is nothing but human readable language, C, C++, Java, whatever language we are giving, that is a high-level language. That is the input of the compiler, and it produces the intermediate or low-level language, mission-level language, or assembly-level language. And if any errors is there, report to the compilation errors if any. This is about the compiler. Coming to the interpreter, an interpreter is a program that directly executes a high-level source code line by line into the machine code at a runtime. Examples of the interpreted compiler: JavaScript, Perl, Python, Basic. So these are the interpreted languages. And the preprocessor is a program that processes the source code before it passes to the compiler. It modifies the source code according to the preprocessor directives and produce the pure high-level language program, which is then compiled. High-level language program is the input of the preprocessor, and it is pre-processing. It produces the pure high-level language program, pure high-level language, and that is the input of compiler. And the output of the compiler is assembly level language program, ALP program, assembly language program. So then assembler reallocate mission using link loader or the linker, and it produces the absolute mission code. Now this is the structure of the compiler, structure of the compiler or phases of the compiler, and it is having the 6 phases, and front-end phase and back-end phase. The first 4 lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generated is called as a analysis phase, and code optimizer and code generated is called as a synthesis phase. And coming to the source program is the input of the lexical analyzer. So that is the first part of the lexical analyzer. Second phase is the syntax analyzer. Third phase is the semantic analyzer. And fourth phase is the intermediate code generator and code optimizer and code generator. And another side is symbol table manager as well as the error handler. So let us see each and every phase, what happening in the each and every phase. Lexical analyzer, it is the first phase of the compiler. The compiler that convert the source code into tokens. Token is nothing but tokens are identifiers, keywords, and a token is the smallest meaningful unit: keywords, identifiers, constants, operators, and functions. The lexical analyzer scans the code character by character and groups them into the tokens based on the language rules. It simplifies the input from the next phase of the compilation. Now let us see, for example, the input is integer a comma b, then it is a one token, it is a keyword, and a is a identifier, this is the one keyword, and so this is a one token, b is the one token. The lexical analyzer read the input string from left to right, character by character, and it produces the tokens. The tokens are nothing but keywords, identifiers, constants, and operators. Coming to the second phase, syntax analysis. In this phase, compiler that ensure the source code follows the grammatical rules of the programming languages. It verifies that the sequence of tokens produced by the lexical analyzer is arranged correctly according to the language's syntax. To represent the structure of the source code, syntax analysis use parse tree or syntax tree. So what is a parse tree or syntax tree? A parse tree is a tree-like structure that represents the semantic structure of the source code, and syntax tree is a more abstract version of the parse tree. It represents the hierarchical structure of the source code but with less detail, focusing on the essential semantic structure. So the lexical analyzer generates the tokens and it is passed to the syntax analysis. Syntax analysis produce the syntax tree or parse tree. For example, x equal to a plus b. Then syntax tree for this expression equal to is the operator x and again this is the expression plus and left child is a and right child is b. So this is about the syntax analysis. And semantic analysis. Semantic analysis is the phase of compiler that ensure the source code is logically meaningful or not, while syntax analysis check the structure of the program. Semantic analysis check its meaning. The semantic analysis phase performs the several important checks including the type checking and variable declaration. Coming to the next fourth phase is the intermediate code generation. Intermediate code generation is the phase the compiler in which ensure the source code is converted into the intermediate representation. This intermediate code lies between the high level source code and the final machine code. So see the example a equal to b plus c multiplication d. Then so this c multiplication d is treated as one temporary variable t1 equal to c multiplication d and one more temporary variable t2 and b plus, and this entire term is assigned to the temporary variable t1 plus t1 and a equal to the result is stored in a2. So this is an intermediate code generator. Code optimization. The code optimization is the process of improving the intermediate or target code to make the program run faster, use less memory, or be more efficient without altering the functionalities. So common techniques for the code optimization: constant flooding, pre-computing constant expressions, dead code elimination, removing unreachable unused code, loop optimization, improving loop performance through invariant code motion or unrolling, strength reduction, replacing the expensive operator with simpler ones or less operators. And this is the example code before optimization for integer j equal to 0, j less than j plus plus, x equal to y plus z, a of I equal to 6 multiplies j. So after optimization, this is the code x equal to y plus z for integer j equal to 0, j less than and j plus plus, and a of j equal to 6 into j. So this is called as a code optimization. Code generation. The code generation is the final phase of the compiler where the intermediate representation of the source program, three address code or abstract syntax tree is translated into the machine code or assembly code. Now let us see the assembly code for T1 equal to C multiplication D, T2 equal to B multiplication plus T1 temporary variable and A equal to T2. Here load R1 comma C, load the value of C into R1 register. This value is into R1 register, and D load R2 value, load the value of D into register R2. So this is C is the source one, and this R1 is the destination register. And for multiplication, use the multiple R1 and R2. The result is stored in R1 itself, R1, and store the result in R1. And this expression is evaluated. Load B value into R3 register. Load the value of B into register R3 and perform addition operation on add R3 R1, and the result is stored in R3 itself. R3 equal to B plus C multiplication D, and store the result in R3 register. And store the result. What is the result contain? R3 contain B plus CD, that is stored in A register. Variable store the final result in variable A. So this is the code generation. And symbol table, it is a data structure being used to and maintained by the compiler, consisting of all identifier names along with their types. It helps the compiler to function smoothly by handling the identifiers quickly. For example, integer a comma b, and the symbol table maintain id 1 and so identifier 2, identifier 3, integer a b. So it is used to identify names along with their types. And next one is error handler. Error handler refers to the mechanism used by the compiler in each phase to detect and report and recover from the errors without stopping the entire compilation process. Let us see the one example for phases of the compiler, and what the input is position equal to initial plus rate into 60. So that is the input of the lexical analyzer space, lexical analyzer, and lexical analyzer produce the tokens. The tokens are nothing but position is A. So identified. So this is ID 1 equal to initial is the identified ID 2, and rate is a identified ID 3 multiplication 60. And the lexical analyze generate the tokens. The tokens are ID1, ID2, ID3, multiplications constant value is 60. And these tokens are input of the syntax analyzer. The syntax analyzer produce the syntax tree or parse tree. The syntax tree is like that. So assume this is the one expression and this is the one expression, and this is the root node treated as a root node equal to, and left child is id1. And coming to this part, this is one more instruction, and plus this is the one expression, and this is the one expression, this is the root node plus, and the left child is id2, and again this is the one regular expression, and it is consist of the operator and operand multiplication id3 and 60. So then the syntax analyzer produce the parse tree, that is the input of the semantic analyzer. The semantic analyzer check the type checking, and it is converted as a into 2. The constant value is converted to the into 2 real. And the intermediate code generator, it produces some intermediate code generator, id1 equal to, that is in this expression is id1 equal to id2 plus id3 multiplication 60. Now take the one temporary variable, that constant value is copied to the temporary variable temp1 equal to 60. Then evaluate id3 and temporary variable. Now that is a temporary, that is copied to the temporary variable 2. Temp2 equal to id3 multiple by So the 60 is stored in the temporary variable 1, temp1, and temp2, temporary variable 3, id2 plus, and this is entire id3 multiplication temporary variable 1 stored in temp2, temp2, then this is entire is copied to the id1, id1 equal to the result is the temp3. So in the intermediate code generation, it generates the intermediate code, and code optimization, it reduces the code optimization, it reduces the number of lines. Now temporary variable 1 equal to temp1 equal to id3 into 60 and id1 equal to id2 plus temp1. Now we are reducing the code by using the code optimizer. The code optimizer is the reduce the optimized code, and that is the input of the code generator. At the code generator produce the assembly level language program. Code generator produce assembly language program. Then id3 is copied to the R2 register and multiply both R2 register and id3, and move id2 in R2 register, add f, and move id1 value to the R2 register. Otherwise, we can write assembly level language ALP program like this, and move our LDA load 60 to some R1 register, and LDA multiply load LDA or move ID3 R2 register, multiply R1 and R2 register. The result is stored in R1 register. Now R1 register contain ID3 multiplication 60 and load ID2 value to the R3 register and add perform addition operation R1 and R3, and the R1 contain the addition of ID2 plus ID3 multiplication 60. The result is stored in R1 register. Then store the value, store ID1, R1 value is copied to the ID1. This is the assembly level language program. Then at the end of the compiler, it produce, we are giving the input of the compiler, high level language of is the input of the compiler, and it produce assembly level language or machine level language. So this is the example for structure of the compiler. So these are the textbooks and the references. Thank you.